And welcome everybody to the Daily Space Weather. I'm your host Dan, aka smAsho, and today a lot of interesting stuff to cover. Sunspots, coronal holes, coronal mass ejections, plus cosmology. Oh my. Here's a composite view of the closest star in 171 angstroms, ionized iron, as well as the colorized magnetogram. We've got two sunspot groups consisting of sunspot 2811 and 2812. The first one, 2811, is a beta class sunspot. The fact that it has two opposite polarity umbrae, at least, is an increase in the likelihood of solar flares. There still is a possibility of additional coronal mass ejections happening in the next day or so. We'll keep you posted on it. Let's take a look at the coronal mass ejections that have already occurred. I would note the date stamps down at the bottom of the screen there. You're looking back into yesterday here. And some components of that coronal mass ejection that you saw there are indeed somewhat Earth-directed. They might entirely miss. And there are actually two separate components here. There's one expected to largely miss to the northwest, and one expected to largely miss to the southeast. And I'll read you NOAA's forecast on that momentarily. We made a video yesterday afternoon. If you didn't check that one out, perhaps check out yesterday's DSW. I don't remember what we titled it. DSW something or other. A supplemental video about this particular coronal mass ejection. By the way, stereo A is located at Lagrangian point 5 as it trails Earth in its orbit around the Sun. So here's the view from the LASCO C2, which is located here at Lagrangian point 1 on the SOHO spacecraft. And we'll bring this back to the coronal mass ejection. There you can see the largely missing coronal mass ejection to the southeast, which is down here, and you see the one at the northwest up here. Certainly not going to be direct strikes on the Earth. And the more likely component to have an earthly geospace effective portion is the northwesterly one. And you can see a bit of a halo. You can see some ejecta here above the obscuring disk. And we'll show you this on the LASCO C3 as well. It's a zoomed out view of essentially the same thing, also on the SOHO spacecraft at Lagrangian point 1. There you can see a little better view of those sort of two separate events nested in one. It looks like almost all of the ejecta from the northwesterly one is above the solar disk here. Don't be surprised to see these miss entirely, folks. And here's another full disk view of the closest star, El Sol. 335 angstroms, by the way, is another one of the ionized iron UV emission spectral states. Some minor flaring also happening in the past 24. We'll get to it. And if you want to read about the stereo spacecraft, there's a great Wikipedia article about it. It even has some animations about how the stereo spacecraft got to where they were located. They were sent off in opposite directions to reach their gravitational equilibrium points of Lagrangian point 4 and Lagrangian point 5. So perhaps check that out if you like. Here's a chart of the solar system. There's where things will be in a week. We'll be in a gibbous waning in 1 week. And here's a star chart. If you're up before dawn and you have a clear sky, you may see Saturn rising before the sun, as well as some other planets. The question is, where will you be when Deneb sets? And by the way, for you new viewers out there, if you're new here, check out smashomash.com/forum. There is a cosmology forum specifically dedicated to this star, high-mass X-ray binary system consisting of an ultra-massive object orbiting a massive Wolf-Rayet star, which is so huge you would be inside of it. If it were in our solar system, it's about the size of Mars's orbit. Moving on, the 10.7 centimeter radial flux, still at 80 solar flux units. Here's a graph of that to put it in context. The top black line there is the 10.7 centimeter radial flux. The radio output of the upper chromosphere and lower corona gives us great insight into what's going on the sun. In fact, you could guess how many sunspots are there based on just looking at the radio flux. You can see how proportional it is to sunspot number, which is this red line. So here's NOAA's forecast. Unsettled to active geomagnetic levels are expected on the 23rd and 24th of March due to persistent coronal hole high-speed stream activity coupled with the arrival of the March 20th coronal mass ejection. So that's NOAA's forecast, and no further comment on that as the coronal hole wind stream continues. And let's take a moment to look at volcanoes. If you're wondering what's been erupting on an earthly scale, is a volcano like an earthly coronal hole, folks? Well, not exactly. Sakurajima is erupting, though, on the Japanese island of Kyushu. And it's erupting in an explosive fashion, having produced a 6,000-foot plume of ash. Suwanosejima volcanic ash not identifiable in satellite imagery. Please don't pole vault the caldera. Raung on East Java, exploding. It wouldn't be wrong to say that Raung has a 12,000-foot ash plume. Please don't fly your home-built kit aircraft over that. Dakono on the Isle of Halmahera, exploding as well. Flight level 080, it's an 8,000-foot ash plume. 14,000-foot ash plume over the exploding Guatemalan volcano of Pacaya. Fuego has dissipated its volcanic ash, according to probably satellite imagery, I don't know. According to Volcanic Ash Advisory Center, Washington, the Guatemalan Fuego volcano has dissipated its ash. Sangay exploding in Ecuador, producing a 22,000-foot ash plume. Also in Ecuador, Reventador exploding. 16,000-foot ash plume there. And while we're unable to detect whether or not Sabancaya in Peru is erupting, please do not attempt to square dance around the caldera. Fagradalsfjall has been erupting, and I guess the stream has been shut down. They're going to make a time lapse of the eruptions of Fagradalsfjall. Perhaps check that out. Fagradalsfjall, the Icelandic volcano. So today I'd like to invite everybody to check out smAshomash.com. You can find some of our smAshomash.org presents the sun videos there, videos 1 through 9, and there are more on the playlist as well. So check it out, smAshomash.com. We saw the writing on the wall a couple of years ago and created our own website because of the failures, censorship, and nonsense associated with big tech. Today's featured product, oh, and by the way, I'm actually wearing a product that you can purchase from our website. It's the Smasher Price My First Pandemic shirt. Yes. It's an essay on the pathetic and infantile response of mankind to the coronavirus. And you can find a link to that at the smAsho store right there on our homepage. Today's featured product is Fauci Committed Fraud products. And we've got a whole bunch of them, including shirts, hoodies, miniskirt, stickers, prints, bath mats, clocks, bags, comforters, etc. So you can tell your friends and foes that Fauci committed fraud. And by the way, for the next 2 days, today through March 25th, if you use the promo code MAGIC15, you'll receive 15% off any products from the Redbubble stores. So check that out. Again, you can link to that directly at smAsho merch It's a link right on our homepage, smashomash.com. Are you accountable for fraud? Yeah. Let me check the life of the stream before we do earthquakes. And allow me to vanish. Here's the earthquake report over the past 24. No major earthquakes, although one came in while I was making coffee. And about 22 hours ago, we saw a deep quake at Vanuatu, a 4.5 magnitude at 248 kilometers. Here's another deep quake at Tonga, a 4.4 magnitude at 273 kilometers. And that one occurring only about half an hour after the Vanuatu quake. And we're just going to scroll up the list here. Again, no major quakes over the past 24, some in the 5 magnitude range, such as this 5.0 at New Zealand. It's a deep quake, over 150 kilometers depth. Right there, just inland of the Bay of Plenty. There must have been plenty of shaking going on during that 5.0 magnitude. And shortly after that, actually more like an hour and a half after that, we saw a 4.5 magnitude at Fiji at over 540 kilometers depth. Here's another deep quake. So it's a lot of deep quakes there. A 4.6 at Tonga at 170 kilometers, a 4.4 at Fiji at 556 kilometers. So a whole bunch of deep quakes in the past 24 hours, folks. No major quakes. Continuing on. A couple B-class flares happened here. In fact, we're practically in a background B range there for a moment. Sunspot 2812 is pretty large, although it is alpha class. Sunspot 2811 is beta class. And again, the likelihood of solar flares is up a bit, especially with that beta class sunspot. No proton strikes, and we're not expecting any major proton strikes, if any at all. I would forecast we won't see any spikes in this proton flux from the coronal mass ejections that we just covered earlier in the video. GOES magnetometer still looking pretty spiky here as the coronal hole high-speed wind stream continues. There's the 3-day chart of the GOES magnetometer. It's measured by the GOES 16 at the F ionosphere layer. We'll show you where that is momentarily. Here's a top view ecliptic plane field plot. Now we're looking at the heliospheric current sheet. And you can see the Earth solidly in the South Pole-oriented current sheet. The Earth's potential field surface source line shown here in orange. And we are expecting to remain in the South Pole current sheet for the foreseeable future. Keep in mind the data is 1 hour and 31 minutes old and can change suddenly. Also, there is still significant plasma in between Earth and Sun. The likelihood of additional coronal mass ejections remains, especially on the far side of the Sun. But here's the line of sight coronal hole plot. This shows the Sun's B field in blue, and you can see a bit of a B field yank here happening. And you can also see another coronal hole rotating in here, and that's a trans-equatorial one. It's South Pole oriented, and we actually see some green mixing in there. If you look at the last frame, you can see a little bit of green down here. That's a North Pole oriented coronal hole all the way down there south of the equator. Here's the integrated space weather analysis animations of the detected filaments and detected sunspot groups. You can see 2811 on there, and not showing 2812 yet for some reason. But that 2812 is certainly a sunspot. Maybe 2812 wasn't named yet, but I would also note some filaments up here, and we are seeing filaments on the far side of the Sun as well. Don't be surprised to see us cover additional coronal mass ejections soon. We got into a brief state of geomagnetic unrest here. Again, as that high-speed coronal hole wind stream continues. Current KP index, a measurement of global geomagnetism, is at 2. Next, looking at the real-time solar wind, which has been quite steady here over the past 24. We did see a shift in the phi angle happen here recently. Current solar wind density is at around 6.5 protons per cubic centimeter. Current solar wind speed still elevated here over 500 kilometers per second at 514 kilometers per second. Here is 4 hours of geospace magnetosphere movie, And while this plays, I just want to do a quick drawing for you here. When the solar wind shows up, it is split into field-aligned currents. Those protons have to decide which field they're in. Some of them make it closer to the Earth. Some of them get ejected back into space and reintegrated into the solar wind. Quick lesson there while we watch the magnetohydrodynamic pressure. Next, we'll look at changes in the Earth's B field. And we look at this daily because we're interested in changes in the Earth's B field, otherwise known as geospace delta B. So we showed you the Sun's B field a few frames ago. Now we're showing you the Earth's B field, or at least changes in it measured in nanotesla. That is what the geospace delta B is. And it's fairly steady here, no real surprise, no major changes in the solar wind. We stream this live to Twitch if you're wondering where we came from. It's twitch.tv/smAsho. And thanks to our Twitch subscribers, etc. Let's continue on. Reminding our viewers to press like and subscribe, press the share button, and share the channel with your friends and foes. Our regular viewers may be well aware of our capabilities. Let's continue on. To thank our patrons, the real source of funding for the content, perhaps consider becoming a patron if you want the earliest alerts from anybody on Earth. Patreon.com/smAsho is the location for that. Patreon.com/smAsho. And thanks again to our patrons for giving us some semblance of income related to our videos. And feel free to leave us a comment and let us know why you've decided to send us a few bucks per month. Tiers range from $3 to $15 per month. Thanks again, patrons. Let's talk about our mission. We're going to talk about number 5 once again. If you want to read the rest of our mission, head to smashomash.com/forum/mission, smashomash.com/forum/mission. Number 5 is to publish scientific papers in a multidisciplinary manner, including sciences such as spectroscopy, and also including but not limited to the sciences shown on the screen there, like health, wellness, magnetohydrodynamics, etc. Spectroscopy, folks. It's kind of important. By the way, we're also on BitChute, thanks to our subscribers over there. There is exclusive content on all of our different sites, including Twitch, including BitChute, Twitter, Facebook, etc. And let's do a cosmology segment, as we'll be revisiting spectroscopy once again, one of the most important aspects of astronomy. Let's talk about the Big Bang. You may or may not believe the Big Bang was a thing. However, there is an interesting article at phys.org in the Astronomy and Space section regarding the Big Bang. Think of the expansion of the universe as a bread pan filled with dough and raisins. Think of the raisins as the galaxies and the dough as the space between the galaxies. As you expand the dough, the raisins are getting farther and farther apart. Or perhaps put dots on a balloon and then expand the balloon. That is the theory behind the expansion of the universe. Now, of course, some galaxies are blue shifted. Most galaxies appear to be red shifted. And I'm not going to get into the old light problem or anything like that in this video. I just want to refer our viewers to this article here on phys.org in the Astronomy and Space section. It may help you out about mainstream theories about the Big Bang. And today I won't poo-poo on the Big Bang or promote it. I'll just let the article scroll here. And feel free to pause. There are many misconceptions about the Big Bang. So perhaps have a read there, as there are some reasons to believe and some reasons not to believe that the Big Bang was a thing. And of course, one of my biggest problems with the Big Bang is the idea that the Big Bang created a monopole cosmic microwave background, as I think the cosmic microwave background is one of the most ridiculous things in all of astronomy and cosmology. Enough said on that. Today we're not going to pick a random object at all, which we regularly do on the videos in the cosmology segments. Today we're picking a non-random object. It's NGC 6553, a globular cluster located close to the Milky Way's galactic bulge. And I'm going to zoom way out so you can see about where this is located with respect to the Milky Way. It's on the Pan stars. So there you can see the Milky Way there. And if you zoom way in, you'll see NGC 6553. Now, globular clusters are like galaxies within galaxies. Very tightly dense, tightly packed regions of stars, consisting of various different stars of various different positions on the HR diagram, the Hertzsprung-Russell diagram. Let's check it out on the Spitzer. There it is in infrared light. And we'll also show you it in blue. This is the blue light spectrum, which occasionally shows additional features, as NGC 6553 is in the news today. So again, I would refer you to our mission. And notice how the first science that we list is spectroscopy. Why? Well, because radio astronomy is indeed the way of the future, and it's telling us more interesting things than largely anything else. So one of the things about spectroscopy is we look at it daily. For example, here's iron 9 and 10 at 171 angstroms. This is ionized iron, folks, and the UV light that it emits when it's in that spectral state. And what's interesting about NGC 6553 is, well, a couple of things. First of all, the vertical anti-correlation of sodium to oxygen, where there's a spread in sodium, but the variation in oxygen is minimal. So you've got a relatively consistent amount of oxygen across the globular cluster, but a totally inconsistent amount of sodium. Now, this is believed to be about 250,000 times the mass of the Sun, this entire globular cluster. I think it's actually even more than that. It's 235,000 solar masses is the estimated mass of NGC 6553. And I'm going to allow this article to scroll as well. And feel free to pause the video. Don't worry, we'll be here when you get back. Thanks to everybody who tunes in to our YouTube live premieres. And that's today's Cosmology segment. Let's continue on here at the Smash News Network. Least busted. Name and news. And next we're going to move into the realm of electron flux. Here's the 1-year chart of the electron flux, and we are back into electron warning levels here. As the GOES 16 takes measurements of the amount of electrons at the ionosphere level, there's where the level's been over the past year. You can find this chart at solon.info/solar, and here you can see the electron flux is indeed in warning levels. This red dotted line coincides with electron density on this graph. When we report to our patrons, we're looking at pulse flux units. It coincides with the same area. It's just a different thing, folks. Density versus pulse flux units. Anyway, that's a 3-day chart as measured by the GOES 16. Don't be surprised to see some GPS errors, especially around the equator at noon. So here's the electron forecast model. The green boxes show the forecast. The yellow diamonds show the observation. No argument with me there on NOAA's forecast. And here is a visualization of the inner Van Allen belt. This is about a 12,500 mile column of air in between a GPS geosynchronous satellite and your handset. And this will show you where GPS errors are likely to be. We've actually demonstrated it. If you don't follow me on Instagram, it's instagram.com/smashamash. You may have already known about it. And what we were just looking at is the visualization of this portion of the air column through the inner Van Allen belt, which is essentially what you were seeing in that visualization. Next, looking at the ionosphere layer, which is just one layer of the atmosphere, which coincides with this red F at about 300 kilometers. We show this daily as well. While this won't show tiny, tiny anomalies, it will show major anomalies, and we've shown a few recently on the daily space weather video. So if you haven't subscribed to the channel, perhaps you should, as we didn't butt in line. People requested that we report to the front of the line, and so here we are. It is actually looking a little anomalous here in the ionosphere. Places like Central Africa and the equatorial Atlantic Ocean showing some anomalies there. And are you enjoying your spring so far, or your autumn if you're in the southern hemisphere? Leave us a comment and let us know. Here's the latest image looking normal here at 9:15 Universal Time. And again, the ionosphere is at approximately, the F layer of the ionosphere is at approximately 300 kilometers. It becomes an F layer at night, and it becomes a multiple double layer in the daytime. And if you see a red blob, this portion right here, that's an F layer. This is an F2 layer. This is an F3 layer, and so on. Next, looking at surface winds. And we see some strong ones here south of the western portion of Australia. And that does actually coincide with all the way up at the jet stream. There is the jet stream scenario for the eastern world. Some big kinks there around just north of New Zealand. Here are the jet streams of the western world. We'll show you the surface winds as well. Let me just rotate that a little bit. There we go. And we see a tripled up jet stream over the North Atlantic, and some extreme bends in the jet stream here over the central U.S. Here are the surface winds. And continuing on with meteorological subjects, next is the pressure maps on windy.com. Powerful low pressure here over southeastern Australia, as well as a really powerful low pressure up in the Arctic here, north of Norway and Sweden. Powerful low pressure up there in the North Polar region. South Polar region completely associated with low pressure. You can see all low pressure down here over the entire Antarctican continent. And some low pressure over the central U.S. as well. Let's advance this into tomorrow. There's the pressure forecast on the Euro forecast. That's the Euro pressure forecast for where we expect pressure to be. Let me bring that back. That's 1 p.m. tomorrow. Were you aware that true noon occurs at 1 p.m. local time during daylight savings time? It's true, folks. It's true. If you're in the middle of your time zone, the sun will be at the apex of the ecliptic at 1 p.m. during daylight savings time, not 12 noon. Anyway, lightningmaps.org looks like it's back. And for that, we thank you. Blitzortung.org. We're glad you got your servers back. Hopefully you didn't suffer too much financial damage, if any, when your Strasbourg servers burned, rather. They became burnt as they burned. So if you're in Houston, especially if you're in a skyscraper, go out and look north. You may see some interesting phenomenon. Take some time-lapse photos. You may see take some video with your camera. You may see some interesting phenomenon above those thunderheads. It's a very active lightning system here, and we're seeing some around Galveston as well and Lake Charles. And if you use lightningmaps.org, you may even be able to forecast thunder, as you can see here. Sam Houston National Forest, if you're camping right now, you're probably having a bad time. Next, U.S. Doppler radar map, and you can see that heavy band of storms all the way from southern Texas up into Missouri. And it looks like it's taking a plain old northeasterly route. Looks like it's traveling in approximately this direction. We'll give you further insight in the next frames. Here's what's going on in the cloud layer. It's too dark to see it, so we use the NASA GOES shortwave radiation map at 3.9 nanometers. And here's the water vapor scenario. And you can see this dry mass of air in this area here is largely in charge. And we do get a bit of a counterclockwise rotation, causing the situation to stagnate a bit in places like Kansas. And we'll zoom out and show you the full country map here. We don't want to do too much weather pornography in the daily space weather, as it is a fairly lengthy video to begin with. So here is the full lower 48 view in both water vapor and cloud cover. Great view of that. And if the Doppler is not giving you appropriate information, check out the water vapor map. That's the NASA GOES interactive weather satellite, by the way. And it is spectacular. And let me press refresh here. We're going to show you one of the most current images. This one only 1 minute and 51 seconds old from El Teide. Shout out to Creaky Blinder. Tidy. It's tidy at El Teide. And let me press play. A very recent image of the hydrogen alpha filter of the local yellow dwarf, this ground-based system located at El Teide, Spain. And you can see these active regions in the northeast, Sunspot 2811 and Sunspot 2812. Here's what they looked like when I did show prep. And you can see 2811 is indeed beta class. We have multiple umbrae of opposite polarities. Sunspot 2812 still alpha class. Here is the colorized magnetogram. We're going to refresh. And we're going to refresh the intensitygram as well. And there's the current state of affairs. 2811 has degraded slightly in the last half hour. 2812, I think, might have shrunk a little bit as well. And we've got some additional views for you here. Let me refresh that, as we don't want to give anybody a seizure with our 94 angstroms video. Just give that a minute to refresh. Again, we are streaming live, folks. So here's 94 angstroms. Come on, you can do it. I know you can do it. There we go. 94 angstroms, another ionized state of iron. And if you want to see the best temporal resolution, folks, 94 and 131 angstroms. Take 10 images per minute instead of only 2. And you can see a little bit of flaring out of former sunspot 2810, now decayed to plage. And that actually was associated with one of those coronal mass ejections. Here is 193 angstroms. A bunch of coronal holes in the southern hemisphere and a few active regions in the north. Here's nothing. Let me refresh that, folks. I apologize for the flashing. Here's 171 angstroms. My personal favorite wavelength. And I would note another active region rising down here behind the latest series of coronal holes. So that's something to keep an eye on. And when I say ion, well, the pun is intentional. Here's the nothing. That's the last view we've got for you. And we're going to actually bring up one more bonus feature here. We're going to show you the 48-hour SDO 304 angstroms view, as there's some spectacular filamentary behavior down there in the southeast. You'll also see the coronal mass ejection coming out of the North Pole, coming out of the North Polar region there, as well as another coronal mass ejection being emitted from the southeast, which is down here. And that's about it, folks. Thanks for tuning in. Remember, stare at the sun, attempt to understand the physics, don't drink it. If you do drink, don't drive. Seriously, don't drive. I could be out there, and no matter how much I like you, I don't want additional traffic. But in any case, thanks again for tuning in, folks. Welcome to the Neo Renaissance. Visit our links, support the channel in whatever way you're able, and may that solar wind be at your back.